Good afternoon, everybody. I'd like to share with you today an energy vision of the future that many developed countries are already working towards. That is to say, an electric-based, low-carbon economy where the full mix of renewables, and by that I mean biomass, solar, wind and marine, all play a key part to help address our energy trilemma. In the UK, if we just take marine as an example, and by that I mean wave and tidal, there's enough energy in our UK coastal waters to meet all our electricity needs more than 3 times over. But currently, only a tiny fraction of that is actually being exploited. So there's a huge opportunity there. My name is Christopher Biggs, and I am Marketing Director of Seawave Energy Limited. We have designed and developed a wave energy device that delivers huge amounts of stable power reliably and cost-effectively. Before we look at our technology, let's just take a look at the actual potential for wave power in the UK. Okay, on the map you can see that the optimal wave environment is down the west coast of the British Isles. That 69 terawatt-hour figure is in fact equivalent to our total UK coal-fired generation. So that's a massive opportunity for wave. It could replace that at a fell swoop. As many of you know, the UK government is committed to its low-carbon agenda, and it has committed to paying marine, so wave and tidal, £305 per megawatt hour, when in fact a conventional megawatt hour of electricity is currently trading for around £50 a megawatt hour. So the incentive is there for us to make it work. Okay, let's just look at our technology. The waveline magnet device consists of a series of interconnected floating platforms. But when I say floating, that's a bit of a misnomer. We haven't really got time in this presentation to explain how it actually works, but we've got some video footage that we're happy to show to you after this session. But essentially, the device is in direct contact with the surface of the water, and the wave actually passes through the device. And as it does so, its wave height decreases and power is extracted at each one of those interconnections on the platform. In those round pictures, you can see our evolutionary journey. In 2013, we tested in the wave tank at Plymouth University, and these tests were supervised by a group of experts from Exeter. The power outputs were very high, and we have now improved that device, and we built our own wave tank in Cyprus, which is where the WM8 device is now testing. And we would seek that if you are interested in seeing our record-breaking performance figures, you actually come out to Cyprus, bring your experts with you, and see it in action for yourself. Okay, I wanted to talk a bit about the cost of energy. This is absolutely crucial. We reckon that our cost of energy is around £100 a megawatt hour, which is considerably less than a lot of renewables. And if we could actually find out the figures for other marine devices, it would be way lower than that. So we are confident that we have a very competitive price there. I've also put in a benchmark figure for coal-fired generation with biomass, and we're broadly comparable with that. So that's like a legacy power delivery. The waveline magnet array would consist of 22 WM9 units, and working together they would deliver a total power output of over 30,000 megawatt hours per annum, which gives a total revenue of £9.4 million a year. And that is working on a very conservative figure of 30% capacity factor. We think we'd be much higher than that, but we've taken the same figure as the wind sector just to be on the conservative side. Okay, last slide. First of all, we're looking for around £250,000. That would help us complete our wave tank testing program. We'd also like to move that WM8 device to a wave tank where we could replicate more complex wave environments on a consistent basis. Secondly, it will allow for funding the CAD/CAM design of the WM9 device. As a stage 2, we're looking at £1.5 million, which will be basically split between construction of the WM9 device and then deployment at Fab Test, which is a nursery facility off Falmouth Bay. We need a bit of senior management support to help drive the business forward. And if I can leave you just with one thought, it is that, to echo Amber Rudd this morning, we really do have a breakthrough technology. We're challenging the conventional way in which the physics of wave energy is understood. So we are hopeful that we can work with you. We've got a global product. Thank you very much.